Namaste, ladies and gentlemen. Come with us as we travel to the country called the land of unity and diversity, the country of India. But first, let me tell you some details about India. India is commonly known for their diverse culture, religion, film industry, commonly known as Bollywood, an old yet outstanding train network, delicious Indian food, colorful celebrations and festivals, sporting culture, incredible architecture, large population, and lastly, historical mathematicians. Let's dig deeper how Indian mathematicians contributed to the development and innovation of mathematics that we are using today. Don't get bored. Your time will not be wasted because you will learn a lot of new things today. So bear with us as we take you back to the classical period of Indian mathematics. Let's go! Did you know that the ancient mathematicians discovered many interesting and useful mathematical innovations that are greatly used today? There are many significant mathematical inventions in ancient India, but the following are some of those that changes the world. Let's take a look.
Mathematical advancement and innovation. Sulba Sutras. It is considered as the only source of ancient Indian mathematics from Vedic period and was written in the period 800 BC to 200 BC. But again, it was used for carrying out rituals. Sulba Sutras is a list of rules for carrying out fire altars. These Sulba Sutras had a good amount of geometry which was required as altars were needed to be in specific shapes and dimensions like length, height, area, and etc. And also were required to convert one shape of altars to another to maintain similar properties like area. Rules for negative numbers. The various methods and practices of negative numbers were also analyzed in depth by Indian scholars. Brahmagupta specifically wrote a great deal of scholarly and personal work that focused on demystifying the concepts of negative numbers many years before his counterparts in the rest of the world. Brahmagupta specifically demonstrated the rules of subtraction and addition for negative numbers. The rules that he established were later applied or discovered independently by other mathematicians in the West. Similar to Chinese, the Indians early discovered the benefits of decimal place value number system, a more refined and perfected system, which we use in the modern world, thanks to an Indian mathematician, Aryabhata. The earliest use of a circle character for the number of zero was in India, known as Bantu, the ancient Hindu symbol of circle with a dot in the middle, symbolizing the void and the negation of the self. Perhaps was instrumental in the use of a circle character to represent the concept zero. The treatment of zero as a number, though, is a totally different story, which will be discussed later on.
Your curiosity about the mind behind all of those brilliant innovations may have arisen after studying the mathematical innovations made by ancient Indian mathematicians. As we travel to the different places here in India, I'll introduce to you the mind behind the remarkable breakthroughs and improvements in mathematics that we use today. Prepare to be amazed at the different places, and I will take you at the lives and accomplishments of these geniuses. We are here in Pataliputra, our first stop. Pataliputra, adjacent to modern-day Patna, was a city in ancient India. This is where Aryabhata was born.
Aryabhata, an Indian mathematician and astronomer, considered as one of the greatest in his field. Known for his great work Aryabhatiya, a well-constructed work that covered the many facets of mathematics and astronomy. Covered in his texts were the arithmetic, algebra, plane and spherical trigonometry, quadratic equations, etc. He also approximated the value of pi, equivalent to 3.1416, correct to 4 decimal places, and he seemed aware that pi is an irrational number and can only be given an approximation.
Our second destination is the birth of the mathematician Brahmagupta Binmal. Binmal is an ancient town in Jalore district of Rajasthan, India.
Brahmagupta was the foremost mathematician of his time and the head of the foremost mathematical center of ancient India. He was the first to treat zero as a number and define it as a result of subtracting a number from itself in his most famous text, Brahma's Utsa Siddhanta. Furthermore, Brahmagupta's understanding of number as abstract entities resulted in yet another major conceptual leap of the advancement of mathematics. The sum of 3 minus 4, for example, was then thought to be meaningless, or most zero. Brahmagupta, however, realized that there may be a negative number represented by depth and the opposite of priority, a positive volume. He then established rules for dealing with a negative number. A negative multiplied or divided by a negative is positive. Negative times a positive is negative, and so on.
Next destination is Vijayapura. Bijapur, now officially called Vijayapura, is the district headquarters of Vijayapura district of Karnataka, states of India, and this is where Bhaskara II was born.
Bhaskara II lived in the 12th century and was one of the most accomplished of all India's greatest mathematicians. He wrote his first work with full systematic use of decimal place volume. Bhaskara II also developed solutions and foundations for what would eventually become calculus, as well as the second proof of the Pythagorean theorem.
Kingdom of Cochin, named after its capital city of Kochi, was a late medieval kingdom and later princely state on the Malabar coast in South India. Madhava was born in the state.
Madhava is sometimes referred as the greatest mathematician astronomer of medieval India and the founder of the School of Mathematics and Astronomy in Kerala. Unlike most mathematicians, who were rather nervous around the concept of infinity, Madhava played around with it, particularly the infinite series. He even went further, linking the infinite series with geometry and trigonometry. Additionally, the use of infinite series to approximate a range of trigonometric functions effectively laid a foundation for the later development of calculus.
Welcome to the city of Erode. This is where Srinivasa Ramanujan was born. Erode is a city in the Indian state of Tamil Nadu.
One of the most celebrated mathematicians is Srinivasa Ramanujan. Despite not receiving a formal education, he was able to contribute to the advancement of mathematics. Analysis, game theory, and infinite series are the main coverage of his contributions. He came up with the infinite series of pi, and this series made up the basics of certain algorithms that are used in the present.
In our next destination, two mathematicians was born in here. Calcutta is the city of India's West Bengal state. This city was the birthplace of mathematician Mahalanobis and Bose.
Prasanta Chandra Mahalanobis was Indian statistician, graduated with honors in physics and later was introduced to statistics by one of his tutors. His interest in statistics evolved into a serious academic pursuit and applied statistical method to problems in anthropology, meteorology, and biology. Mahalanobis even established the Indian Statistical Institute in Calcutta. Furthermore, he devised a measure of comparison between two data sets, the Mahalanobis listheads. Satyendranath Bose was an Indian physicist specialized in mathematical physics, known for his work on quantum mechanics, providing the foundation for Bose-Einstein statistics and the theory of the Bose-Einstein condensed state. Additionally, he worked on the particle statistic and clarified the behavior of protons and opened the doors of new ideas on statistics of microsystem that obeys the rule of quantum mechanics.
We are now in Huvina Hadagali, the birthplace of Kalyampodi Radhakrishna Rao. Huvina Hadagali is a town of Vijayanagara district.
Kalyampodi Radhakrishna, an Indian-American statistician, credited for shaping the field of statistics into a structured and organized form. One of his most significant contributions is the introduction of the concept of quadratic entropy as a general measure of diversity within a population, a concept that is widely used to study diversity in population in the fields such as biology, sociology, economics, etc.
Our next destination is Dahanu, the birthplace of Dattatreya Ramachandra Kaprekar. Dahanu is a coastal town and a municipal council of Pargar district of Maharashtra state in Konkan division.
Dattatreya Ramchandra Kaprekar was an Indian recreational mathematician who described several classes of natural numbers including the Kaprekar, Harshad, and self numbers and discovered the Kaprekar's constant, named after him. Despite having no formal postgraduate training and working as a school teacher, he published extensively and became well known in recreational mathematics circles.
For our last destination for today, I welcome you all to the city of Gwalior. Gwalior is a city in the central Indian state of Madhya Pradesh. This is the birthplace of Narendra Karmarkar.
Narendra Krishna Karmarkar is an Indian mathematician. Karmarkar developed Karmarkar's algorithm. He is listed as an ISI highly cited researcher. He invented one of the first probably polynomial time algorithms for linear programming, which is generally referred to as an interior point method. The algorithm is a cornerstone in the field of linear programming. He published his famous result in 1984 while he was working for Bell Laboratories in New Jersey.
Hi! And we are now in the last part of our tour. A moment ago, we taught you about the history of Indian mathematics. I assume you were able to grasp them, like how the Indian created the Sulba Sutras, which listed some of the basic Pythagorean triples or the Surya Siddhanta that contains the root of modern trigonometry. Did you take note that the Indians were the one to create the place value system that we use in modern times? Have you listed the significant mathematicians of Indian mathematics, such as but not limited to Brahmagupta, who treated zero as a number and developed a negative numbers? Aryabhata, who argued that pi is not a rational number, and Madhava, who played the concept of infinity. I hope this tour helped you broaden your horizons about the Indian mathematics and that it was able to inspire you to learn more about the history of mathematics as well as mathematics itself. And that's the end of our tour for today. Thank you and God bless. Goodbye!